The name of this topic is Complex Fraction Made of Sums Involving Rational Expressions. So we're asked to simplify this, and it can look intimidating having a fraction over a fraction, but not really. If you remember, this just means divide. So what we're going to do first is find the least common denominator of both of these fractions so that hopefully we can get rid of them and we won't have a fraction over a fraction. Well, the least common denominator of 12 over x minus 4 and 10 over x minus 4 is, of course, x minus 4. So that means we're going to multiply the top of this and the bottom of this by x minus 4 over x minus 4. Okay, that's allowed because it's just like multiplying this fraction by 1. So that will look like this. Here was the original problem. We're going to multiply by x minus 4 over x minus 4. So we have to multiply this entire top piece by x minus 4, so it's parentheses, and the entire bottom piece times x minus 4, so this is also parentheses. So here you see the problem written out like this. 12 over x minus 4 times x minus 4, we're really just using the distributive property here. Recopy the plus sign, and 6 times x minus 4 written out here. So that's just been distributed, which you've done before. Okay, now we need to use distribution here. And you do x minus 4 times 10 over x minus 4. Here you see that here. And then x minus 4 times 5, which you see here. Okay, now comes the fun part. So now we can cross cancel. This will cross cancel with this. This can cross cancel with this. We can actually then distribute as the next part the 6 times x minus the 6 times 4. So what you'll see for that is 6x minus 24, and we can distribute the 5 times x minus the 5 times 4. So you'll see what that looks like here. Now, make sure you see how we got from here to here. Let me show you again. This cross canceled with this, leaving the 12, which you see here. This cross canceled with this, leaving the 10, which you see here. This part is the 6 distributed here. This part is the 5 distributed there. Okay, so now the next question we need to ask ourselves is there any actual math that we can do here? Sure. We can do 12 minus 24 for negative 12. We can do 10 minus 20 for a minus 10. So now we're almost done. All the like terms have been combined. Now we're going to factor the numerator and the denominator. The numerator can be factored into 6 times x minus 2. The denominator can be factored to 5 times x minus 2. Aha! So that is helpful because this can cross cancel this for a final simplification of, if this cross cancels with this, we're just left with 6 over 5. So that is the final answer. Okay, let's do another one of these. So we're asked to simplify this. And if you'll recall from the last problem, one of the first things we want to do is find the lowest common denominator of this and this, because if we multiply the top and the bottom by the lowest common denominator, then perhaps we could get the fractions to go away. So the least common denominator of 1 over x plus 5 and 6 over x plus 5 is x plus 5. So we're going to multiply this and this both by x plus 5. So when we do that, it looks like this. Here's the original fraction. We're going to multiply both of those times x plus 5. So here you'll see distributed this. We have to do x plus 5 times 1, which you see here, x plus 5 times 1 over x plus 5, which you see here. Here, you'll see this distributed. X times x plus 5, you see written here, minus 6 times x plus 5, you see written here. So now we can start cross-canceling to see what we have left. This can cross-cancel this. This can cancel this. So then we're left with the 1, which you'll see copied here, the 6, which you see copied here, the minus 6 here, the plus 1 here. The top numbers were derived from 1 times x, which is x, 1 times 5, which is 5. The plus 1 was here, now it's here. The bottom numbers are derived like this. X times x is x squared. X times 5 you see is 5x. The minus 6 is written right here. So now what we want to do is factor as much as possible to see if there's anything that can cancel. So on the bottom, we can factor that to be x plus 6 times x minus 1 if we factor the denominator. The top, we can't factor, but we can collect up all the like terms because 5 plus 1 is 6, which you see that written there. So now that the bottom, the denominator, is factored, we see that we can cross-cancel this and this. So what are we left with? We're left with x minus 1 on the bottom. In a fraction, we can't just have a blank on the top, so we have to have 1. So we're left with 1 over x minus 1. And that is how you solve complex fraction made of sums involving rational expressions.